Welcome to the geometry unit video for skill number 84. I can find the measure of segments formed by intersecting lines in a circle. Alright, so this skill consists of circles with lines intersecting, and we're going to be trying to find the lengths of segments of lines intersecting circles. And we have three conditions. The first condition is when you have chords running through the center of a circle, or not even the center, but just the inside of a circle. And then we have the condition where two secants intersect a circle and meet at a common point on the outside. And then the third condition, which is a secant and a tangent. And interestingly enough, the secant-secant scenario and the secant-tangent scenario is pretty much the same scenario. What we know is that if you have two chords, then the product of AE times EB is equal to the product of CE times ED. And I kind of shorthand that to say that left, right equals top, bottom. So the left side times the right side equals the top side times the bottom side. So if we were to come up with some examples here, if this was 6 and this was 4 and this was 8, we'd say 6 times 4 is 24 equals 8 times what? And we find that ED is 3, because 8 times 3 is 24 and 6 times 4 is 24. In the secant-secant scenario, what we have is the full length times the outside length is equal to the full length times the outside length. So whole outside equals whole outside. So if we had 2 and 10, and then we had 3 on the outside, and we wanted to figure out what that x value was, we'd have the whole 2 plus 10 times the outside, and that would be equal to the whole 3 plus x times the outside. So 2 plus 10 is 12, times 2 is, we get 24 equals 3 plus x times 3, and we can divide both sides by 3 and get 8 equals 3 plus x, and we find that 5 is equal to x. So that segment DC is 5. In the next example, the same scenario happens where it's whole outside equals whole outside. So if we had 2, 6, and we were trying to figure out this side, we'd get 2 plus 6 times 2 equals the whole length x times the outside length, which is also x. So 6 plus 2 is 8, times 2 is 16. 16 is equal to x squared, and we find that 4 is equal to x. So our value here is equal to 4. On page 84B, I just do 4 or 5 examples, and on the first case we have two chords that intersect inside the circle, so we get left times right equals top times bottom. 2 times 10 equals 4 times x, and we solve the missing length to be 5. In the second one, we have two secants, so 9, which is the whole, times the outside, which is 2, is equal to x plus 3 times 3, and we find that x is equal to 3. In the next one, we have the whole x plus 4 times the outside of 4 is equal to the whole of 10 times the outside of 10. And we solve that out to find that x is equal to 21. Next one is like our first example where we have two chords. 12 times 20 is equal to 8 times x, and x is 30. And then the final example is like our second one where we have two secants. The whole length 6 plus x times 6 is equal to the whole length times 5. And we find in this case our answer is not a clean number, but is rather a fraction. If we were to reduce the fraction, we'd get 7/3. Alright, for this lesson we have 3 scenarios. The first scenario is where 2 chords intersect inside of a circle. The second scenario is where two secants intersect outside of a circle. And then our final condition is where we have a secant and a tangent intersecting outside of a circle. And in this case, we have left times right is equal to top times bottom. In the second case, we have the whole length times the outer length is equal to the whole length times the outer length. And then our final example, we get the whole length times our outer length is equal to the whole length times our outer length. And generally we'll look at these 3 scenarios independent of one another, though it should be known that sometimes you might get a combination of 2 scenarios where you use information from one to feed into the second part of a problem. Thank you.